Hello, I'm Alan Siebenthaler, Marketing and Territory Manager at Hamilton Kent. Welcome to our latest webinar, Sealing the Deal, Best Practices in Gasket Selection and Quality Assurance. As one of North America's leading suppliers of gaskets for underground infrastructure, Hamilton Kent has over 65 years of first-hand experience supplying products to cities, municipalities, and other infrastructure owners. Hamilton Kent manufactures products for the underground infrastructure in two ISO 9001-2008 certified plants, one in Winchester, Tennessee, and the other in Toronto, Ontario, where our head office is located. In this webinar, we will outline the process of gasket quality control, storage, field usage, and best practices. Getting the most of your investment in gaskets requires proper gasket care and quality control, both of which we will outline here in detail. Why is gasket quality assurance important? Here are the top reasons. There is a slim margin between having a watertight joint and a problem in the field. Gaskets are meant to provide a firm fit between the spigot and bell, so if there is much excess or deficit in the amount of rubber in the gaskets, there is a potential for busted bells or failed vacuum or hydrostatic tests. By regularly checking the dimensions and properties of your gaskets, you are helping to prevent this type of problem. By ensuring the correct gaskets are in your inventory and that they meet the physical requirements, the contractor will receive the correct gaskets. One important service you can provide customers is training and instructions on proper gasket installation. This is especially important if the customer is changing to a new gasket. Here at Hamilton Kent, we put installation instructions in the boxes of all TSS gaskets because they are very different than the gaskets some contractors have used previously. All of these points boil down to two important results. The gaskets perform properly, and your plant saves money by reducing or eliminating complaints and field service calls. Ultimately, that's the comfort level you want with your gaskets. What exactly is required of quality assurance personnel with regards to gaskets? Here's what QCAST and NPCA programs require. First, a plant must ensure that the correct gaskets are being used for the correct application. It could be an expensive problem if gaskets sent to a project did not have the physical properties needed to meet the specifications. Second, plants must maintain an annual certification of the physical properties of the gaskets they are using. This document is provided by your gasket supplier and is usually on their website. An example of what ours looks like is pictured here. Third, QCAST certified plants are required to measure the physical properties of a sampling of their gaskets. For NPCA certified plants, they must measure gaskets annually, but no additional testing is required provided the gaskets come from an ISO 9001 certified plant. Plants also must maintain in-house reports verifying the dimensions of the gaskets. QCAST plants must also demonstrate the equipment and procedures for checking these dimensions for sanitary pipe and manhole gaskets. The exception is if your plant utilizes a third party. Note that this cannot be done by your gasket supplier. It must be an independent company. For QCAST certified plants, the testing frequency for gaskets is as follows. For the smaller sizes, 33 inches and below, it's one gasket for every 300 purchased. For the larger sizes and for manholes, it's one gasket per 100. For NPCA certified plants, the testing frequency for all sizes is one of every 300. QA personnel must conduct the following tests and measurements. The strength of the splice on the gasket. This is the area where the rubber strip has been spliced to form a round gasket using a splicing tape or glue. If a gasket is going to fail physically, it will likely occur in this splice. The gasket volume will be checked for solid body gaskets, so excludes pre-lube gaskets. For O-rings only, you must check the core diameter. The cut length must be verified for all gaskets. The hardness of the rubber or durometer must be confirmed. And finally, for pre-lubricated gaskets and profile gaskets, the height and the width of the gaskets must be measured. So now let's look at how these tests are done. Let's first take a look at splice strength. There's really no special equipment needed. As you can see here, a sturdy handrail and a colored marker were all that was required. Your QA person will make a visible mark 1 inch on either side of the gasket splice, so you have two marks 2 inches apart. Then the gasket is stretched until those marks are now 4 inches apart. Then the splice is checked for tears or cracks. Please note you should not bend or twist the gasket at the splice. This puts unnecessary force on the splice that will not be experienced when the gasket is stretched onto the spigot in the field. A simple stretch is all that is required. Certification also requires testing of gasket volume and diameter. This is for solid gaskets only, as you cannot properly measure the volume of pre-lubed gaskets with the rolling tube. For volume, there are three simple methods. The first two involve submergence of the gasket into water and then measurement of the displaced water or the increase in volume within the container. The final method requires weighing the gasket dry and completely submerged in a tank of water and comparing the weights. The QCAST and NPCA manuals have detailed information on these methods, or you can get recommendations from your gasket supplier. For measuring the diameter of an O-ring gasket, you must measure at 0 and at 90 degrees on both sides of the splice, and then take the average of those four readings. A tool similar to the one pictured here would work very well. Next, you must measure the cut length of the gasket. We recommend the following non-destructive method. On top of a large flat surface, place a long, flat measuring scale or tool. Next, make a mark on the gasket to set your index point. Then start at the index mark on the gasket at 0 on the measuring scale and roll it carefully along the scale until you come back to the index mark on the gasket. This measurement is then documented. It's a pretty simple process, and afterwards you can put the gasket right back into inventory. Next is testing the hardness of the rubber, also known as durometer. As shown here, there are two different types of durometer gauges you can use. Obviously, the handheld one on the left would be easier to use in the field or at a location in the plant away from your QA lab. You must measure the durometer on both sides of the gasket splice. This involves pressing the point of the tool into the gasket and reading from the gauge. The average of these two measurements is then recorded. Because gaskets have a variety of configurations, we urge you to get a recommendation from your gasket supplier on where to take durometer measurements. If you test in the wrong place on the gasket, you could get a bad reading, either high or low. For profile and pre-lube gaskets, you're required by QCAST and NPCA to measure gasket height and width on both sides of the gasket splice. The average of these measurements is then recorded. As you can see in the inserted document, we have supplied the dimensions that would be needed to be confirmed for this particular gasket, the TSS 135. Not only are the nominal measurements for both height and width provided, but also the tolerance for each. There is also a drawing provided showing where the measurements should be taken. This is the type of information that is not only useful to your plant, but also required for your records by certification programs. Let's finish up with some basic suggestions gained from our experience with gaskets and working with our customers. First, please note that the cut length and percentage of stretch of gaskets supplied by two different manufacturers will vary. Gasket suppliers will want to calculate what they feel is the best gasket for your joint and will do so based on their own product offering. We recommend that you do not mix gasket suppliers on a project, or at least not on the same size of pipe. If there happens to be a problem at a job site, and it could be related to the gaskets, you want to be able to easily identify who supplied the gaskets so you can get their assistance right away. Now, getting into storage practices, we strongly suggest that pre-lube gaskets not be hung on a wall at your plant. The lubricant inside of the rolling tube is a liquid and will eventually settle to the lowest point. If a gasket is hung on the wall for an extended period of time, the portion of the tube closest to the hook will likely have little or no lubrication, which means it will not roll properly. This means closing the joint in the field will be inconsistent and possibly lead to failed or broken joints. We highly recommend using a first in, first out storage practice. This can save a lot of money in the long run. Gaskets stored inside and at a moderately reasonable temperature will have a shelf life of about 3 years. If stored outside or in excessively hot conditions, this life could be much shorter. If your plant is not rotating your gasket stock very well, or at all, you may end up with old gaskets stuck in the back that will eventually have to be discarded. By the way, gaskets stored outside should at least be covered with tarps to protect the boxes and the gaskets from the elements. Here's what you want to avoid. Once these gaskets start falling all over the place, guys in the yard will kick them around, throw them away, or leave them to deteriorate. In any case, this is definitely not protecting your investment very well. In closing, Here are a few final recommendations regarding field use of gaskets. Good installation techniques must be followed. We know it can be tough to persuade contractors to change their ways, but especially in the case of a new gasket, you must take the initiative to ensure they are doing it the correct way. In the case of non-pre-lube gaskets, this means proper equalization and lubrication. Contractors operating in cold environments need to take special care. If gaskets are left out in the cold prior to installation, they'll feel much harder, and the insertion forces required to close the joint will be much greater. Therefore, trying to warm up the gaskets prior to installation will help greatly. Watch pipe installation to make sure contractors bring pipe home level and square. If the pipe is being lowered into the trench with the spigot down, and it is set into the bell before lowering the backside to the ground, the gaskets can be knocked off the spigot, or even worse, moved enough to cause problems with homing. Similarly, manhole risers and cones need to be lowered into place as level as possible. This will help ensure even pressure between the gasket and the bell until the joint is closed. If the gasket does come off the spigot and onto the ground, and it has just been lubricated, it will need to be thoroughly wiped down to ensure there is no dirt or rock stuck to it, which could cause installation problems. Check to see if there is any damage to the bell or spigot from handling at the job site. Contractors are not usually very delicate, so the bell or spigot could have been cracked or broken. Thank you for attending this webinar. We regularly publish new webinars and hope to see you again soon. If you have any questions or comments, please feel free to give us a call at 1-800-268-8479. You can also browse our website, hamiltonkent.com, for more information.